Welcome to the TWIML AI podcast. I'm your host, Sam Charrington. Before we get to today's episode, I'd like to send a huge thank you to our friends at Qualcomm for their support of the podcast and their sponsorship of this series. Qualcomm AI Research is dedicated to advancing AI to make its core capabilities, perception, reasoning, and action, ubiquitous across devices. Their work makes it possible for billions of users around the world to have AI-enhanced experiences on Qualcomm Technologies-powered devices. To learn more about what Qualcomm is up to on the research front, visit twimlai.com/Qualcomm, Qualcomm. And now, on to the show. All right, everyone, I am here with Flora Tasse. Flora is head of computer vision and AI research at Streem, a company that she joined through the acquisition of another company which she co-founded, Selerio. Flora, welcome to the TWIML AI podcast.
Thank you, Sam. It's a pleasure to be here. Thanks for the invite.
It is a pleasure to have you on the show, and I'm really looking forward to digging into your recent CVPR presentation. You did a keynote at the AR/VR workshop at CVPR. I was excited to see that there's enough happening at the kind of intersection of AR/VR and machine learning to, that there's a workshop at CVPR on that topic.
Yeah. There's tons happening. It was awesome. There's tons happening in that space. So it was definitely a good workshop. Yeah.
Well, you can tell us all about that, but before you do, please share a little bit about your background and how you got started in computer vision, how you came to found Selerio, how you ended up at Streem. I'd love to hear all of it.
That would be a long story, but I'll try to make it short. So I was born and raised in Cameroon. So Cameroon is in Central Africa, and more precisely in the city of Douala. And so I was raised in the French-speaking part of the country. So you might notice that from my accent. There's some French in there. And so from a very early age, I was very much into special effects and movies, and more precisely Jurassic Park. So I was a big fan of the movies because of the dinosaurs. I would I would sit like this close to the TV, staring into a dinosaurs and wondering, how can it be? Like, why is it so real? And then I'll ask my dad, like, how can they make these extinct creatures look so realistic? And then he said, graphics. It's like, okay, yeah, that's what I'm going to do. Like, that seems like my perfect dream, making the impossible become possible. So fast forward a few years, I did my bachelor in maths in the English-speaking part. So I had to learn English and then move and did maths because they had no course in computer science. So then moved out of the country to South Africa, where I did a master in Cape Town. Beautiful city in South Africa.
Cape Town is beautiful.
Yeah, it's amazing. I recommend it. It's a great vacation spot. Anyway, so I did my master's there, then came to Cambridge for my PhD. So 2012, I arrived in the UK, all ready to make my dreams come true. And so that was definitely like a good experience. So at Cambridge, I was looking at how do you take real things in images and turn them into 3D content. So I was doing some 3D shape retrieval, shape analysis from images.
Meaning you have a 2D image and you want to turn that into a 3D shape.
Exactly. Yeah, that's exactly what I was doing. So 4 years or 3.5 years, I stumbled upon like a great discovery that if you actually incorporate NLP, so if you incorporate language information, you can basically get really, really accurate results going from 2D to 3D. And so the addition of that, so the concept was that rather than just looking at images as just pixels that you can then turn into some features and then use classification on them, it was a concept that those features can actually be semantic features. So there's some semantic meaning attached to those descriptors that you are generating.
Okay.
And so
What's
that
an
means that
example of the text that would associate or would be associated with an image?
so yeah, the very early version was just so if I look at the chair and know it's a chair, so I have like my data set has labels like this is an image of a chair and this is a chair. And what we are trying to do is create a representation that captures both of those information. So it captures both the visual information and the text information, which in this case is just the semantic meaning of what the word chair is. So in language processing, they have a lot of language models. So that's what they use for translation and other NLP tasks. And they do this by representing those words as multidimensional vectors. And so what we were doing was creating a representation that will capture both the visual data and that language-based representation. Using that, it will capture semantic data inside the representation. And since that is actually, you have the same concept in 3D shapes, in hand-drawn sketches, you can use that as a way of bridging the gap between all of these domains. That was my PhD, basically. And so we had really good results, really increased the baseline by like 30% in some of the use cases.
Wow.
And so that was great. And the question is, what happens next? What do we do with this? And so there were some offers on the table, like big companies I could go and work for. But I was really passionate about that specific discovery and how we could scale that to not just one object, but like multiple scenes. Can I then take a picture of my room, of my living room, and then turn each object into a 3D shape and build like a scene graph of my surrounding? And so that became Selerio. That's what Selerio was doing. So spun out that work out of the university, created a startup called Selerio that was looking at how do you take the real world and turn that into a digital format. Yeah,
And
the
you were
story
at
is
that for
really
how
long.
long before Streem came along?
2.5 years.
Okay.
Yes. So it was a great like journey. We got to like build something that was running on the phone, had it tested by a bunch of like AR developers. It was a really cool and interesting journey. And during that testing phase, Streem was one of the people who were testing our platform, looking to integrate that into their product. And we had met Streem like a year ago because we have a common investor. And so we really like what they were doing. And so Streem is all about remote collaboration and how do you add value to that using augmented reality. So you take a video collaboration platform and then you incorporate AI at the very core of it. And so they were doing that for like really amazing use cases like repairing, customer support, home repairs, and so on. And so they came with us with an offer because they saw what we were doing as very core, so like the vision of their product. And we were very interested in like bringing this tech to the real world. So we had been hard at work building the technology, and we were really happy about the results, but we couldn't wait to actually see that being used by real customers. And Streem had one of the best use cases for AR. And so that's how the acquisition happened.
That's awesome.
A year ago.
Congrats.
Thank you.
And I guess I'll say before we get very far, we will link in the show notes to your slides from the AR VR workshop. And folks who are listening should definitely check them out because there are a lot of cool videos and demos and things like that in the slides. So, maybe tell us a little bit about your talk and kind of what some of the main points that you're presenting.
So the talk was entitled Computer Vision for Remote AR. And so a lot of time when people think of AR, VR, they think of a mobile phone, they think of a headset, they think of,
Pokemon.
like, yes, basically. And like they would think of like an experience where you are looking at something and then you have something augmented on top of that. So remote AI is very different because someone else across the ocean is kind of experiencing what you are experiencing, but they're not in that same physical location. And so then I was talking about what remote AI is and how computer vision can then help solve some of the issues that take place in that kind of scenario. And more precisely, I was looking at the Streem use case, what we do, and how we are using computer vision to solve some of the issues. One of them is something like meshing the environment. So a quick example, if I'm here in my living room and I have an issue with my fridge and I call one of these companies, I call their customer support and say, I have this issue. Now they can use Streem and the augmented reality platform that we've built so that the expert, we call it the pro, on the other side can have visibility into my environment and what I'm looking at. And so sometimes one of the main main question that they have is, can we measure things? We want to be able to measure something so that if something is broken and we have to send something over, we know what size it should be. How can you make measurement more accurate? And it's really hard to do that on an image. And so one thing that we do is being able to build a 3D mesh of the environment. And so once you have a 3D mesh, then the pro can just say from point A to point B, what is the distance? And so things that are important is meshing, like the geometric data, but also the texture data, because once you have texture, it gives you context. And so
the meshes that you build or are working with, are these based solely on 2D data, or like the iPad now has a LiDAR sensor in it?
Yes.
It's got to make the job easier.
Yeah, definitely. That has been, I look forward to more devices having depth sensing. So we definitely have a framework that we built in-house for doing meshing from only 2D images.
Okay.
But that wouldn't be nearly as accurate as using depth sensing, definitely. Yeah. So we have different solutions depending on the capability of the device that the customer is using.
Okay.
Yeah.
And is the building the 3D mesh from the 2D image, talk a little bit about is that a largely solved problem? Is it still like really hard? Like, where is it on the spectrum of, computer vision, AR types of challenges?
Yeah, it's still really hard. So it's a solved problem, as solved as it can be. What people are now doing is adding AI for predicting depth, but there are still some challenges around using predicted depth for meshing because you need temporal covariance. So as you go from frame A to frame B, you need things to be kind of correct. You need the depth to be current across the different frames. So that's still something that people are looking at. So for the vast majority, most people are using motion stereo. So you look at consecutive frames and you are trying to find depth values that are consistent across multiple frames. And so that is going to be harder if you have frames that don't have much texture, depending on the changes of lighting. That still will be tricky. So people are now looking towards like stereo systems or devices that have depth sensing. So there's not much work going into meshing from 2D images. There's not that much work going in there because there will always be some limitations because of just the nature of the problem.
And the stereo use case that you're describing, is that assuming multiple cameras?
Yeah, so some of the techniques that people are using from 2D images is like using motion stereo. So you kind of look at two images from the same camera, and if they're close enough, you can simulate stereo. And obviously you also have like phones that have left and right images. In that sense, you can just like make the problem easier because you don't have to try to rectify, images that are happening at different timestamps.
I'm sorry, I interrupted you. You're going through these use cases that you see, and one of them is measuring things.
Yeah, measuring things. I'm just making the point that for measuring things, meshing and texture are very important. And so part of my talk was, how do you attach texture to a mesh that is changing all the time? And how do you do that in a way that's real time so that it doesn't interrupt the customer experience? So that was one of the big points I talk about in the presentation.
Okay. Well, let's drill into that. Is that something that your research is focusing on at Streem?
Yeah, so that's one thing that we are actively working on. So a lot of prior work, if you look at some of the mesh reconstruction framework out there, they will give you a color per vertex. So they don't really have, so the colors kind of look really washed out and blurry. And so it's kind of hard to like make out the edges of, a countertop in the mesh. And so we see texture as a big part of, making that easier, making it's easier for people to be able to like make out the context and the edges. And so it's become really tricky to like, most of the time this is happening, the texturing process happens after the meshing. We are trying to do that in real time as the mesh gets updated all the time. So that is what makes it very challenging. And that's the research problem that we are working on.
And so the textures that we're talking about also, like at some kind of texture estimate or something per vertex?
Yeah, so you have like a mesh that you obtain from, it doesn't really matter where you got it from.
Yeah.
And you have some video and you are trying to and you know where your camera is. So at any moment in time, you can say, I'm at this point looking into this direction. How can I use that information and apply that to my mesh?
Okay.
And the camera is moving all the time. The video has blur. So how do you then like kind of try to make a mesh that looks good, with as least like with no artifacts? So that's that's a problem that you look at.
And is the end application in trying to apply the colors and textures to the mesh, are you essentially trying to create a 3D model of whatever the camera's seeing someplace else?
Yes, because not only you are doing that, you are trying to, so this is remote AR, right? So this could be shared with one person, multiple people who are looking at the same scene, and they actually can they can insert 3D elements and things like that. So not only you are trying to do this meshing, this texturing, you are also trying to sync it across devices. So there's a lot of networking challenges that come into place when you start doing these things.
I'm wondering why I need the mesh to be very accurate if I've got the video stream.
So because it's really hard to do measurements in a video stream because the camera is always moving. So if you're a professional on the other end, you pretty much have to say, oh, like, can you just be still for like the next 20 seconds while I take this measurement? And the measurement won't be accurate because you might be clicking at some place, but actually it's not, it's the pixel or the vertex data at that location is not that correct. You're actually looking at something behind, let's say behind the fridge instead of like on the edge of the fridge. And so when you have 3D information, it gives you just more context. You can rotate the mesh and then make sure that you're actually clicking the right endpoint.
So then having the color and the texture information associated with the mesh allows the person who's remote to make sure that they're clicking on the right things.
Exactly. Okay. So they are the experts, so they know how to take these measurements. Usually they have to come into the home to do this, and in the home they are in 3D, right? Because they are in the location. So how can we kind of replicate that experience in a remote setting where they are not physically there? So that's where like 3D information is so important. And if you fast forward like in a setting where you have headsets, then obviously you can put on your headset and you can actually walk around the environment and feel like you are in the physical location.
And again, with the color and texture, you want, certainly with the headset, you want to have a situation where you're kind of walking around navigating the world and the video might not be there anymore. Or the video might be pointing in a different direction or something like that.
Yeah.
Okay, cool. So texture, texture as a big element of measurement was one of the big points that you went into. What were some of the other cases you covered?
So one thing that we don't see much at computer vision conferences, or even AR, VR, applications, is just being able to extract metadata from the environment. So more precisely, if you are looking at, say, a washing machine and a pro is looking to fix this washing machine, it's very important for them to know what is the serial number, what model are we looking at.
Right.
So that's like the bread and butter of customer support. And and then the customer usually don't know this information, or how do you, or kind of like they are focused on the fixing part of it, not necessarily on the data collection part of the process. So one of the computer vision problems that you have is how do you look at a device and be able to extract information about model number, serial number, especially from labels. So some of these devices, they make it easy for you to have labels. But then can you look at text and know what text is relevant and what text is associated to a serial number or to a model number?
Right.
So that's the metadata extraction part of what we do.
Having repaired a bunch of home appliances, or at least attempted to, and seen a lot of these labels, they have all kinds of numbers on them, and trying to figure out which ones are the right ones. It sounds similar to looking at some other kind of structured or semi-structured text, like a document, like an invoice, and trying to figure out what's the invoice number and what are the line items and that kind of thing.
Yeah.
And
it can be so hard,
the
right?
orientation is probably going to be weird, and the perspective is probably going to be weird, and the lighting is probably going to be bad.
Definitely. Like we deal a lot with like skewed angles, like depending on where you are looking from, it can be very distorted. Adding to the fact that like manufacturers have very different standards. So you can't have like a rule-based system that says, oh, like we'll always be looking at, this area of the label. So AI, this is where like AI really comes handy. Because we just basically look at it as a two-part problem. First, it's an OCR problem. So how can I just extract textual data from this image? And then it's, which part are relevant to what we care about. And so that becomes like a classification problem based on the textual data, based on where it's located, train over a lot of labels and a lot of data. We can now kind of look at the label and tell the pro, that this is the serial number, this is the model number of this appliance.
For the OCR part of that, are you kind of taking the image as is and pulling the letters out, however they are? Or are you trying to reorient that kind of as a, ortho rectification process so that it's straight?
No, so we leverage a lot of like the existing frameworks for OCR, because OCR is just about taking some image, getting text out of it.
Yeah.
So you can do a lot of like a lot of data augmentation that happens in this. So these type of models have done a lot of data pre-processing.
So they're already pretty good at, at extracting text that's not straight.
Yeah. Okay. Yeah. So we don't have to worry about that part. So the biggest, so in this case, the biggest effort is like building a model that is going to do the classification right, because obviously like OCR just gives you random text, and in the case of CR, these numbers, they might occur in different places. It might be like some at the top, some at the bottom, and then the OCR might gives you groups, but those groups could be like very disjointed. So how do you combine this information into something that makes sense? That's where our focus is on. Less on the OCR, more on like making sense of the OCR output.
And are you using as a feature in that part of the problem the actual text that might say, model no or serial no, or are you kind of ignoring that and just looking at trying to do it based on the number itself?
So we do it based on the whole text. So from the whole text, we will basically classify, we say, okay, we care about the serial number. What bits of this text represent the serial number? And we do that by training a model that does that. So implicitly, the model is using all of this, like, implicit information around like where this is there like a serial number on top, behind, before, and so on. We don't explicitly do it, but I think it's implicit in the trend. It's a fun problem.
There were some other use cases that you walked through?
Oh yeah, one of my favorites is always, so when you talk, so going back to what I was saying around like blending what's real with what's virtual and having like this immersive environment, one of the key thing that I'm very excited about is walkthroughs, like tutorials, but tutorials in AR. Okay. So you get a new appliance, you want to know how to get started, we can have an AR tutorial experience around that machine to tell you how to like use it. Like it's broken, and then you can have a troubleshooting walkthrough around that appliance. And so for me, that's like one of the most fun use case because it gives the power back to the customer. And one of the key problem in being able to do that is being able to identify the 6DOF pose of whatever appliance you are looking at or whatever object you are looking at. We need to be able to know what is translation, rotation, so we can then impose data, like virtual data around it. So I talk a bit about how we do 6DOF pose estimation for objects like that.
And elaborate on what that means, because I saw that in a presentation. You write it as 6D, and it's like 6D. Yeah, what are the six?
6DOF. Well, 6DOF is 6 degrees of freedom.
Mm-hmm.
So 3 for translation, 3 for rotation. So that makes this. That makes 6 variables that you have to estimate in order to like get a pose transform for where your object is with respect to your camera.
Got it.
Yeah.
Got it. So you've got you're locating an object in 3D space, and it's got some rotation, and that can change in its next position.
Yeah.
Okay.
So it's so at any point in time we are trying to figure out what are those 6 values so that you can build a transform from that, and then you can use it to impose your 3D content around it.
Okay.
Yeah.
And so maybe what are the challenging parts of that problem?
And it's one of, even today, like I think for the past, as far as I can remember, people have always been working on pose estimation. Even this year at CVPR, there are so many papers around that because it's a very hard problem to solve. For us, it's even harder because you are actually not looking at the image, you are looking at a video. So your camera is changing and you expect that pose to be correct across multiple frames. So for us, we use a combination of techniques. So at CVPR, you see a lot of work around pure ML-based techniques, where you can just give an image to a model and it will tell you what are those 6 values, or it will tell you what are the key points. So if you have like the key points of your object, you can recover the pose information. So what we saw with those techniques is that they are not nearly accurate enough. Like typically you have like a 10 degrees margin of error, which is for us not good enough because we are going to be superposing content on top of this in AR, so that we need like super accurate pose. So what we end up doing is we have a combination of like getting some ML-based technique to identifying key points, or even just asking users to like select those key points. And then we focus on like from that initial pose, how can we refine it further to really fit the edges of what is currently in the image. And so these are called region-based approaches, where it's looking at what is the background, what is the foreground, and how can we find a pose that best differentiate between the two. So those are very accurate for this type of use case.
Okay, it sounds like in this case, a big part of the way you improve your results is by kind of manipulating the user interface so that you can get more information without it being overly burdensome on the part of the person who's using it.
Yeah, so that's so we try, because accuracy is so important for us. If we need some user input, we need to leverage some user input to get to that level of accuracy, and that's something that we are happy to do. And in a sense, it also helps us collect more data so that we can also improve the accuracy of our models.
Have you seen many products out on the market that are kind of putting this kind of AR in the hands of the consumer? Like you mentioned this training use case for a washing machine or something. Is anyone doing that?
I haven't seen anyone doing that. So I think like Streem is in a very good position because we have like an existing customer base who are actually asking for these kind of features because they see that as a big need. And so that's kind of driving the problems you are working on. So I think I haven't seen it out there yet. So maybe people are working on that like behind the scenes.
I was just going to say, I've seen a lot of demos of it in a kind of industrial type of use case, like at one of the Microsoft conferences a year ago, their CEO Satya Nadella demonstrated a kind of remote repair. A worker goes into a telecom closet, out in the middle of nowhere, and they're trying to figure out how to, get the 5G working again or something. And there's they're supported by someone who's pushing overlay screens on top of what they're seeing and telling them how to fix stuff. The closest I've seen to it in something consumery is, I don't know how, it's kind of prosumer / low end enterprise, and it's actual, I think, is real as opposed to a demo. But there's a networking company, Ubiquity Networks, that makes these, again, kind of prosumer networking gear, and their latest line of switches, in some of their promotional materials, they're showing you kind of holding your phone over these switches, and they're showing you like what's connected to what in the different ports.
Yes.
But that's probably the only example I've seen of that actually in the wild.
Yeah,
and
it's
looked pretty cool.
Yeah, definitely. Like and I've seen, obviously, like AI Kit has some demos around, like being able to, if you have like a Lego set, and then you are able to kind of recognize that and then impose some 3D content around that. So there's definitely been some demos around this type of use cases. More so when you mentioned Microsoft, I was just thinking, oh, it has a depth sensor. That would make our life easier.
The Connect sensor type.
Yes. That's why I can't wait for more depth sensing to come to phones.
But you're assuming just a phone, and so
exactly,
you're only able to use things that are commonly available on phones.
Yeah. So definitely, the world where what is going to happen is that, like, on phones that don't have depth sensing, we have these techniques. On phones that do have extra capabilities, then we can offer, we can use that data, that's sensor data, to even push further the accuracy of our methods. So the more devices with those, like, the better.
What are some of the other big challenges that you see in the space?
In our space, okay, so one of the big, so at the end of my presentation, towards the end, I mentioned spatial AI and
spatial AI?
Okay. And what it meant for us. And for us, it just means that going beyond trying to understand these tasks at a granular level, but like look at it big picture. So at the end of the day, what you want to know is, in a video, in a collaboration between two people, what is the problem? What is the solution? What are they talking about? And how do you capture this information in a way that you can then reproduce it somewhere else? And so, you have this idea of bots, chatbots. You have this everywhere, like in the banking systems, where you have an issue, and then they can just kind of, based on your question, they will suggest you something. And if they can't fix that, then it will escalate to a human being.
Okay.
And so I take that AI and I add spatial AI on top of that, in the sense that now this AI both actually, they understand your environment, they can look at what you're looking at, and they can make sense of it. So ultimately, can we create agents that are able to to help you solve these issues without you needing to actually talk to a human being? That's kind of like the big moonshot problem that you are looking at, beyond these individual computer vision tasks. Yeah.
So I'm envisioning, as an example there, the the cliched scene we see in the movies where the bomb squad comes in to defuse the bomb. Someone's holding their phone over it, and the system, as opposed to some remote expert, is saying, "Oh, it's definitely the yellow cable. Clip the yellow cable."
Exactly. They better be right. They better be right, and make no mistakes in that kind of scenario. But that's what some of the things that we are thinking of now is, how do we start getting there? By maybe like starting by making sense of the video data. Like, can we start clustering videos by the functionality? So not just similarities, in the sense that they have similar scenes, but are they trying to solve similar problems? And so how can you capture that out of a video and be able to start creating these clusters, which can be very useful for just like training, for a company to understand understand like what are the most common issues and capture, what are the solutions to these issues so that they can replicate that in other environments.
Mm-hmm. It
So
sounds a little bit like you're describing kind of going back to expert systems types of approaches for, but coupling that with information that we've pulled using modern AI techniques, neural networks and the
yes.
like. Am I hearing that correctly?
Yeah, spatial expert systems. So
Spatial expert systems.
our mission at Streem is making the world expertise more accessible.
Okay.
And so how do you open access to to everyone? And so that's part of how we get to that vision.
Okay.
Yeah.
Do you follow the computer vision space more broadly, or is it,
I do.
what
I
do you
do.
find interesting at CVPR this time around?
Oh man, like obviously I'm always kind of looking at more like problems that you are already looking at. So one of the work that I read recently was normal assisted depth estimation. And so in the sense you're not looking at one image to predict depth, you're actually looking at a couple of images, which for me is really interesting because then you just get extra information and you make sure that whatever you're outputting is consistent across multiple views. And so for me,
It sounds
that's
like the stereo problem that you were describing
yes,
earlier.
but using AI, which is good because you can now scale across like different type of scenes and you can build robustness to like lighting issues and so on, which you can't do with like traditional methods. So that's very interesting. I'm still like reading through. There's a lot of content at CVPR, so I'm still working my way through everything that was presented. But definitely, that's one of them. And just in a general sense, I'm very excited about machine learning without needing label training data. I think that's a big. I think people are still looking at that. So I'm less interested in being able to like generate photorealistic images. I know there's a lot of focus on that, but I really think of like machine learning and computer vision, and you look at all of these models, they need tons and tons of data to train them.
Yeah.
So there's definitely some line of work around how do you basically do self training systems. How do you do that without needing like a bunch of data, label data? So that's something that I'm very interested about.
Nice. The workshop that you presented at, is this something that you've been participating in for a long time, or is it new at CVPR?
So this is the second year
Okay.
the workshop is taking place. So last year I was attending and we were presenting this scene generation from images work that I mentioned earlier. We presented that at the workshop, and I was invited for this year keynote, for one of the keynote this year. So I was definitely like, I was glad to have the platform to talk about our work.
Yeah.
Yeah, it's a great workshop. I kind of encourage everyone to go and check the other speakers because there was a lot of work around just like the vision of AR VR. What's stopping us from from everyone doing conferences through VR? Like, why are we not doing that
Yeah.
today? And things like that. So that was definitely awesome.
Interesting. Yeah, I did. I organized a conference a few years ago, and we had a presenter on AR, VR, and kind of some of the implications for machine learning, but it was super early. Like there was nothing really happening. And so it's exciting for me to hear that, the field is advancing and there's particularly, and is it fair to say that AR in particular, because the scenes need to be understood more, there's more implications for machine learning than VR, which tends to be more kind of generative and
Yeah,
scripted?
yeah,
Is that
yeah,
what you're seeing
definitely.
as well?
Yes. So a lot of these tasks in augmented reality, we need machine learning because no one is there's no time to sit down and try to like like manually take a real scene and then
Yeah.
create a digital. So if you're gonna do like physics interact, if you're gonna interact with the environment, then you need to understand that environment, and that's computer vision. That's what computer vision is all about, taking reality and making sense of it.
Yeah.
So it's very crucial to augmented reality.
Well, Flora, thanks so much for taking the time to share what you're up to. Very
Oh,
cool
thank you.
stuff.
I'm always happy to talk about these things. Yeah, thanks, Sam.
Nice. Thank you. All right, everyone, that's our show for today. For more information on today's show, visit twimlai.com/shows. As always, thanks so much for listening, and catch you next time.